Implicit differentiation. Now, we have a couple types of functions that we deal with. One being an explicit type of function, which is a function with only a single variable, okay, where one function is dependent on, or one variable is dependent on another. So, for example, your basic concept of that would be, y equals 2x plus 5, or f of x is equal to x squared minus 2. Something pretty simple like that. So Alright. So implicit differentiation is something like your equation for your circle. X squared plus y squared is equal to 16, or an ellipse or hyperbola. So those would be implicit differentiation because it's not dependent on a single variable. Okay. Now, which means when we do the derivative of these, we have to do these a bit differently, because when we do a derivative, we are taking the derivative according to a specific variable. Okay. So, for example, the derivative of x right here in terms of x, d dx of x is just 1. That's just 1 dx over dx. Now, dx over dx is just 1, so 1. All right, derivative of x squared would be 2x dx over dx, which is just 2x. All right, derivative of your exponential function would be 5e to the 5x. Again, dx over dx, which would just be 5e to the 5x. So we don't really include the dx over dx every time, because anything divided by itself is 1. Okay, dx over dx is just 1 in that case. So we don't have to worry about it. But when we're doing the derivative of a different variable, we have to include it. Okay? So when we do the derivative of y according to x, this is going to become 1 dy over dx. And it stays. When you do the derivative of 2 y squared, it becomes y2, or 2y dy over dx. Okay, same down here. This is 5e to the 5y dy dx. Now, what is dy dx? What is dy dx? It is just another form of y prime. So, dy dx is just another form of y prime. It's a very good question. In the past, I usually did just write y prime, and you can if you want. But there's a reason why I'm kind of focusing on dy dx, and that's going to kind of be more apparent in the next chapter. Yeah. When we do related rates, you're going to be doing derivatives of multiple different variables according to time. So again, when we do related rates in chapter 4, we're going to be doing derivatives according to time. And I'm really glad people ask questions and don't pay attention to the answer. So it makes me super happy as a teacher. I'm glad that's also on the recording. So whoever gets to listen to that gets to hear me complain. All right, moving on. So here are your steps. Here are your steps. First, take the derivative, and anytime we take the derivative of y, we are going to include a dy dx. So if we take the derivative of y squared, we get 2y dy dx minus 15x squared is equal to 3 dy dx. Yes. So we have our function y squared minus 5x cubed equals 3y. We took the derivative. Every time we have a y, we take the derivative of y. We include dy dx. Second step is to get all your dyx's or dy dx's on one side and everything else to the other. And again, usually it says to the left. Just it's a good habit to get it to the left. So that means I'm going to bring this 3 dy dx over. So 2y dy dx minus 3 dy dx is equal to 15x squared. So subtract the 3 dy dx over and add the 15x squared to the right. Third step, factor out the dy dx. So dy dx times 2y minus 3 equals 15x squared. And lastly, to get dy dx by itself by dividing by what's in the parentheses. So dy dx is equal to 15x squared over 2y minus 2.
We would just leave it like that.
That's your answer. Mm-hmm. So this is what's known as a differential equation. You have a derivative in terms of x and y. This is a differential equation. That's really everything we're going to do. That's really the big thing for the day. We're just going to practice this quite a bit. Okay. So again, the big thing you have to take away is anytime you do a derivative of a variable according to a different variable, so in this case, anytime you do a derivative of y according to x, you have to include dy dx. So, what is the derivative of y cubed? Dy dx. Minus 2. Now, because it's x, we don't include the dy dx. Only when it's y do we include the dy dx. So only on the y cubed and the 2y, when we do the derivative, do we have a dy dx. Because what it's saying is we just took a derivative of y according to x. So that's step one. Step two is to get all your dy dx's on one side, everything else on the other.
Ready for students whose last names begin with R through S. You may head to the auditorium lobby at this time.
So that's going to give you 3y squared dy dx minus 2 dy dx equals 4x cubed plus 2. All right, so factor out the dy dx. And then divide by what's in the parentheses, and you're done. Now, number 2 is tricky. Is chain rule. And since I know you guys did the homework over the weekend because you didn't have anything else to do, right? So
Yeah.
we should have practiced plenty of chain rule from last Friday. Yeah, it's fine.
Because there's a lot of like,
Well, we'll have an example chain rule right here. Stop. So remember, if you remember chain rule, we do the derivative of the outside function. In this case, the derivative of the outside function is sine. What's the derivative of sine? So cosine xy times the derivative of what's inside. Now the fun part is the inside part is product rule. Yeah. So for this, we do the derivative of the first part. So the derivative of x times y. What's the derivative of x? 1 times y plus the derivative of y, which is dy dx times x is equal to 10.
Right.
So just to refresh that, we do the derivative of x times y plus the derivative of y times x. So now we will have to distribute because we need to get the dy dx by itself. So we will have to distribute the cosine xy through. So we are going to get y cosine xy plus distribute this times that, all right, plus x cosine xy. I'm going to leave the dy dx at the end. Yeah, you're welcome. So all we did was multiply both the 1y times cosine xy and the x dy dx by cosine xy. It is just another form of y prime. Really is so you can take derivatives of implicit functions. So we need to get dy dx by itself, so we're going to get rid of the y cosine xy. So it leaves you with x cosine xy dy dx is equal to 10 minus y cosine xy. And then lastly, we divide by x cosine xy. Just in case, there is another way to write this. And that is divide both your numerator, your 10, and your y cosine xy by cosine xy. So another way to write this would be dy dx is equal to 10 secant xy minus y over x. Just in case.
Well,
Again, if you're given multiple choice, you're not always given the way that you want to write it, are you? Uh-huh. If you divide 10 by cosine, secant is 1 over cosine. So if you divide 10 by cosine, you get 10 secant. So if you divide each of these by cosine, it's the same. So kind of the in-between step here would be to write this as 10 over cosine xy minus y cosine xy over cosine xy over x. So that's the in-between step. Now, if you were given free response, the very first one would have been fine. The 10 minus y cosine xy over x cosine, that'd be fine. But if you're given multiple choice, you may not always be given the same way that you want to answer it.
What choice to get?
Yeah, it's where most people have trouble in tests. Then. Don't worry about. Not. No. So let's. What are gonna be in? No. So then, yeah. So number 3, find the equation of all tangent lines for when x squared plus y squared is equal to 4. Now first, when x equals 1. Now x equals 1 in 2 locations. That would be here and here. So we have 2 tangent lines. Okay. Now we do need to find the actual coordinates for those. So when x is 1, that's 1 squared plus y squared is equal to 4, which means y squared is equal to 3. So what does y equal? Plus or minus root 3. So this would be the 1 positive root 3, and this would be the 1 negative root 3. What we want to find are the tangent lines. Now, looking at this, we're most likely going to get the same slope, but one is going to be what? Negative. One's going to be positive, one's going to be negative. And you can kind of tell that the one up here, the slope is going to be negative. Because, again, obvious downward direction of the line. And here the slope is going to be positive. Now we do need to find the slope, which means what do we have to do to the function? Got to find the derivative. So that is 2x plus 2y dy dx. That again. Equals 0. Because derivative of 4 is just 0. So all we have to do is subtract 2x over. So 2y equals dy dx. No. 2y dy dx equals negative 2x. Which means if we divide, what do we get? That dy dx is equal to what? Negative x over y.
Yes.
Yeah. Now, do we know what x and y are?
No.
Yeah, x is what?
Beginning T as a Tom through V as in Victor. If you need to have your photo taken, please head to the auditorium lobby at this time.
So at 1 root 3, that is going to give you, my slope is negative 1 over root 3. At 1 over, at the coordinate of 1 negative root 3, that is going to give you, my slope is negative 1 over negative root 3, or just 1 over root 3. So we already said that we do know that this was going to be positive, the other was going to be negative, so we're good. Now, it does want the 2 equations, and I don't really have room to write it down here, so I'm going to put it up top here. My first equation, y minus root 3 is equal to negative 1 over root 3 times x minus 1. Second equation, y plus root 3 is equal to 1 over root 3 times x minus 1. So there's the 2 equations. Now, this next part will be on your test. Now, this will be on your test. This implicit differentiation, you will have implicit differentiation on your test. But this is another part that people had trouble with, so I want to warn you ahead of time. All right? When you do implicit differentiation, pretty much every time we did implicit differentiation, we got fractions, right? Okay. Will it happen every time? I don't know. Probably. It happens a lot. Now, when you get fractions, when is your tangent line going to be horizontal? What is a horizontal tangent line? What's the slope of horizontal tangent lines? 0. So when is a fraction equal to 0? Numerator equals 0. Okay? Now, to get a vertical tangent line, that means the slope is undefined. And when is the slope undefined? The denominator equals 0. So anytime they ask for a horizontal tangent line, you just set the numerator equal to 0. Anytime they ask for a vertical tangent line, you set the denominator equal to 0. Now, for these questions, they want you to find the coordinates. Okay, the coordinates for when you have a vertical or horizontal tangent line. Okay. So, find all horizontal tangent lines to this function. Now, the nice thing is both these are the same function, so we only have to do the derivative once. So we do the derivative, that's going to give you 6x plus 4y dy dx is equal to 0. We get rid of the 6x, so 4y over dy dx is equal to negative 6x. And then divide by 4. So dy over dx equals negative 6x over 4y, or negative 3x over 2y. So, for the horizontal, all right, we take the numerator and set that equal to 0. So, negative 3x is equal to 0, which means x is what? 0. So what we want is the coordinate, so we take 0 and plug it in. 3 times 0 squared plus 2y squared is equal to 16. So basically 2y squared is equal to 16. Y squared is equal to 8, which means y is equal to what? Root 8, which is plus or minus 2 root 2. So my coordinate would be 0 plus or minus 2 root 2.
Sorry, what is CO again?
What is what?
CO.
Sorry, coordinate?
Or
No, that's parentheses, not C. Coordinate.
oh well. Well, okay, now.
So we do the same thing for the vertical, but we take the denominator. So for vertical, we take the denominator to y equal to 0, which means y is 0. So that gives us that 3x squared plus 2 times 0 squared is equal to 16, which means 3x squared is equal to 16. So x squared is equal to 16 over 3, and when we square root, we get x is equal to plus or minus 4 over root 3. So 0. There you go. Now, we are not doing 3.3 today. We're going to do, I moved things around. We're going to do 3.5 and 3.6 together, because 3.5 is half a page of notes, and it's just listing all the derivative concepts we talked about so far. So it's not really notes. Okay. And 3.3 and 3.4 are, they're just all kinds of fun. So that is it for the notes. You can go and start on the homework. Oh, you had questions on homework last night. Let's answer those.
10, 13, and 25.
10, 13, 25. Okay. As soon as everybody takes, which isn't going to be until Tuesday now. So Wednesday, hopefully.
Wait, where did the test?
The test corrections are there. I can't give them back to everybody takes them. Yeah. Well, no, Wednesday. Should be able to get back to them Wednesday. All right, so for this, Okay, please. What were you do? Alright. So, what is the derivative of a exponential function? It's itself times the natural log of the base. Okay, so that's the first part. Now we have to also multiply it by the derivative of the square root of x, which is what? Yeah, 1/2 root x. So putting it all together, we get 3 to the power squared of x times the natural log of 3 over 2 root x. You said 10, 13, 25? Okay. Now, for number 13, this has kind of multiple chains. So the derivative of an exponential function with base e is itself. So e to the cosine of 7x cubed times the derivative of the exponent. Now, what's the derivative of cosine? Negative sine of 7x cubed times the derivative of 7x cubed, which is 21x squared. So, given that we have a negative 1 here and a 21x squared, that gives you negative 21x squared sine to the 7x cubed e to the cosine 7x cubed.
X through Z, you can head, or excuse me, W through Z, you can head to the lobby of the auditorium. Thank you.
Answer the one.
Probably looks interesting. All right, so it's 10, 13, all right? 25.
Linear equation. No.
Find the equation of the tangent line. All right, so first we do plug in 1. What do we get with plug in 1? E. Yeah, just E. By the way, what is e to the 1? It's not 0, it's not 1, it's E. Okay. So now we need to do the derivative, so g prime of x would be what? E to the x squared times 2x. So g prime of 1 is 2e. So y minus e is equal to 2e x minus 1.
You go to the 29.
1? Oh, that's fun. Okay.
Also, you are fine. What is and what is
Just tired. That's a
Get 1200. And I go to work. Not tired. We don't have time.
yeah.
You get paid to do this.
That's fair.
We're paid. That's where my life is.
Put your job in.
So let's see here, 3x. So chain rule here. This is quotient rule and chain rule together. Now here's the thing. Could you just make this easier? How could you make this easier?
No.
Fucking neck.
What? Once. Plugging in with Bryce. You know what you make this in? Your own.
Rewrite it. Now it's just power rule.
See, you did the square into
Yeah. Just square the numerator, and then divide by x. What's the power rule for this? 9, that's gone, plus 16x to the negative 2.
So why 16? Yeah, why is it worse?
because it's technically being divided by.
Because when you divide it by x, negative 1 is just 16 over x. So that means it gives me 9 plus 16 over x squared. And if I plug in negative 2, that gives me 9 plus 16 over what?
What? Is it 18? I'm not.
Oh, it is 18. Thank you. I forgot to do 2 times 9.
Well, damn it.
Yeah.
You kidding?
All right. Yeah, I said, how does this equal 5? How does that equal 5?
What?
I'm saying that you could. Equal. Yeah, let me do this real quick.
No.
Wouldn't be surprised if there's a mistake going on.
Yeah. You get a calculator, right?
No.
Not for the next 18 minutes.
I was like,
Gives you 5. Yeah.
so how do we do it that way? Because I'm confused.
You made it easier for us.
Oh, that's because it's plus 16 here, which will make that minus 16.
What is turning the negative to again?
That could be like 4 that's possible.
So the derivative will make that negative. Still,
That doesn't make it equal
that
5.
doesn't make it equal 5.
Can we design normal? No, can we not do
There you go.
just keep it kosher?
There's got to be a way to do that, though.
Really not cool. I've never been to a beautiful color.
It's not equal. There's not. Why did you do the
Incorrect.
If you do the derivative of 9x squared, you get 18x. That's because that's 18x. Okay, yeah, let's just do quotient rule.
Yeah.
I'm making it harder, trying to make it easier. I'll look over it. Well, I'll figure it out later.
No, you won't.
Yeah, because it'll drive me crazy if I don't. All right, that's fine. I don't mind that. All right, h prime of x quotient rule would be what? The derivative. What's f prime of x? Sorry, what's f prime?
Great question.
Just 3.
3 minus.
Well,
3.
If this top part is f, what's the derivative of the numerator?
5.
well, we have 18x minus
3. What?
6 times 3x minus 4.
Nine. Nah. I'm really sleepy. What?
Yeah, where were you Friday?
What MC?
Oh, no, he was.
And did you not watch the video?
What is it about?
You kind of missed an important lesson. I'd go back and watch that video.
We just all watch the video together and we make like.
Tell you what, yeah, go right ahead. Have a party with it. All right. So 6, 3x minus 4 times x minus derivative of x is 1 times 3x minus 4 squared over x squared. 6 is 3 times 2.
It's on the outside.
Doesn't change, but. Oh.
Plug in negative 2. So 6 times 3 times negative 2 minus 4 times negative 2 minus 3 times negative 2 minus 4 squared over negative 2 squared. So that gives you negative 6 minus 4, which is negative 10. Negative 10 times negative 12 is 120. And that gives you minus 100 over 4. So yeah, 20 over 4 is 5.
Why? Where in the heck?
It's because it doesn't become 18 when you do, yeah. That's why.
Yeah, because there's no.
There was no squared. It doesn't become 18, leaves 9. So when you do the derivative, so this is h of x, h prime of x would just be 9 minus 16 to the negative x squared, or to the x squared.
Yes.
So, which gives you, if you plug in negative 2, that's 9 minus 4, which is 5. There you go. That would have been easier. Somebody didn't tell me it was 18. All right. I didn't listen. So yeah, that would have been easier. No, that's the only one you could do that on, though.
You just really out. That's the next one. You do.
Anything else?
Resources that can